Hi, and welcome back to the Unit 2A.1 Electrons and Electron Configuration video. This is part 2. So if you saw part 1, you know that in this unit we're trying to answer the essential question, which subatomic particle is most important? And since in Unit 1 we've learned about protons and neutrons, we're going to focus in this unit on electrons and learn about some of their qualities that will help us answer that question. So in the first part of Unit 2A is we're looking at how the electrons are arranged in an atom. And we're using sort of two systems here. The Bohr model system, which I covered in part 1, and the electron configuration model. Now, one of the things that we discovered in the part 1 video is that the Bohr model is actually limited. So when drawing the Bohr models for iron, which was the last example we did there, using the rules that we had, we came up with a configuration like this, where there was 2 in the first shell and 8 in the second, third, and fourth shell. But it turns out that the electron are arranged this way, where you have 2 in the first shell, 8 electrons in the second shell, 14 in the third shell, and only 2 in the fourth shell. So we sort of need to figure out why this is. And that leads us to our electron configuration. Okay, so that's what we'll focus on here. Now, electron configuration, one way of sort of thinking about it is how one would arrange residents in a dorm building. So in your packet, and if you don't have your packet open or available to you, you definitely want to get to it. And I'll just pause and tell you where it is. It's in the Unit 2A folder. And this was the week 1. And this was done on Thursday. Okay, there should be 2 items in there: the essential question document, which you need to fill, do your take 1 for that, and it should be this electron configuration. Now for this document, you can print it out, or you can just look at the document on the screen, and on a separate piece of paper, write out your electron configuration. So if you need some time to do that, take a moment to. Okay, so in this exploration, what folks are doing is that they're following these rules to fill up a dorm room with residents, okay? So if you want to take a moment to read the information in the beginning, you can. Now there are 3 rules to filling up this dorm room, the dorm building. The first one is to fill from the bottom up. So you're going to fill the rooms on the ground floor, and then you move your way up. The second rule is singles first. So on each floor, you're going to place people in singles rooms first, so 1 in each room, before doubling them up. And then finally, opposite direction only. So in a room that has a maximum capacity of 2, when you place people in the room, they must be facing opposite directions. Now in this first example here, we have a situation where we have 9 students ready to reside in that dorm building. And to represent the students, we're going to use arrows, an up arrow or down arrow, to show which direction that they're facing. And you're supposed to take a moment to fill up these 9 students in this dorm building represented here. So these are the different floors. So just a reminder of the rules. You're going from bottom up, so you would fill here first, and this room, then these rooms, and so on. Next one, remember, singles first. So when you're filling up a room, for example, here, you put 1 and then you can put another, because there are no other rooms at that level. The next level, the same thing. But when you come here, you have 1, 2, 3 rooms. So remember, let's say you have 4 people, you put 1 in each one before you double. And finally, make sure they're facing opposite directions. So if you have 2 people in the room, they need to have an up arrow and a down arrow. All right, pause the video now and try 1 and 2. When you come back together, we'll talk about what you should have. All right, so this first example, you had 9 students. We're filling bottom to the top, so you should have something that looks like this. My first 2 I put there. And these are abbreviated arrows. So when I draw an arrow, I oftentimes draw it like that instead of like this, just so you know, okay? So up and down. So that's 9. I start with 9. I use 2, so that's 7. I have 5 now. So I have 5. Remember, I put 1 in each one. 5, 6, 7, 8, 9. So let's just check that. 2, 4, 6, 8, 9. Perfect. These are my 9 students. Okay, now let's try it for the one with 31. The same process. So start from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Next level. 13, 14, 15, 16, 17, 18. Next level. This one's up right above it. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. Okay, so let's just count, make sure we're good. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 29, 31. All right, so now, what is this all about? This dorm building represents the orbitals of an atom. And the orbitals are where the electrons, you can think of them as residing. They reside in the orbitals. Really what the orbitals describes is the probability of finding an electron in that space, okay? So the space where an electron is likely to occupy. But anyway, it's good to think of them like a room. And as you can see, the electrons have a very specific arrangement. And so each of these boxes represent an orbital, okay? When you have a collection of boxes like this, that's what's called a subshell. And each of these exists at different energy levels. So this is the arrangement of the electron using the orbital diagram. But we want to do something that's more like this because it's kind of hard to draw these orbital diagrams. We want to do something more like this. So how do we do that? What we're going to do is use the electron configuration abbreviation, and that's quite simple. So what you do there is, first thing is you're going to write the subshell or the orbital that the electrons reside. So in this, from the bottom to the top. So we start with the 1s. Okay. So the coefficient in front, the number in front tells you the energy level, and then that tells you, the letter tells you the type of orbital. The next thing we're going to do is describe how many electrons we have there. So in the 1s we have 1, 2 electrons. So then we're going to use a superscript, which is the small number on top, to tell you how many electrons. Okay, let's go up to the next level. The next one is 2s. We just write 2s, and then we have 1, 2 electrons. That's our superscript. Next one here we have 2p, and we have 2, 4, 5, so we write 2p5. Okay. All right, let's try it with the one where we had 31 students. Okay. So here we start with 1s. There are 2. And we go to 2s. And there are 2 electrons in there, so I write a superscript of 2. Now we're in the 2p. 2, 4, 6. Now it's the 3s. 1, 2, right? So 3s, 2. Then 3p, 2, 4, 6. Next was 4s2. And 3d, 2, 4, 6, 8, 10. So 3d, 10 electrons in there. And then finally 4p1. Okay. So notice that I'm using the term students and electrons interchangeably, and that's because this dorm room analogy is really representing what happens to the electrons. So the students are clearly the electrons. And to clarify this analogy, on the second page of that packet, you have sort of an explanation of what the analogy means and the principles, those rules that we follow at the bottom. So take a moment to read that page, okay? All right, so let's get into some more practice. So we want to do some more of these, right? But now instead of using the dorm room analogy, let's look at some actual atoms. So here we have, our first one is chlorine. The first thing that you need to do in order to write your electron configuration is, just like you did before, you need to determine the number of electrons. I didn't write that here, but that's a step that I'm going to put down. Okay, now since chlorine is neutral, it's going to be the same as the atomic number on the periodic table. And in this case, that will be 17 electrons. So we have 17 electrons that we're going to fill in here. Now you follow the same rules you did before. So bottom to the top, singles first. Okay, so remember when you do singles first, if you have 4 electrons to put in the 2p, they don't double up. You do 1, 2, 3, and then double. And then the final thing, opposites only. You don't want them both spin up. You want one up and one down. And the explanation for why that is, just briefly, is because electrons are sort of like magnets. And just like with magnets, you want a north pole and south pole facing each other. That gives them a little bit of stability. Okay, so you got your 17 electrons. Go ahead and fill that up and see if you can get the right electron configuration. All right, so if you did the first one correctly for chlorine, you should have 1s2, 2s2, 2p6, 3s2, 3p5. Now, if you didn't get that correctly, you might want to go back to the previous part of the video and take a look at that to see how to do it. So I'm going to give you time to do the rest of these. Remember, if you have ions, you have to be careful about how many electrons you have. Like, for example, sodium, +1 charge. And the other thing I will note to you is that number 3, so there are 7 practice problems. Number 3 and number 7 are tricky. So I want you to do them how you think you do them, and I'll show you the correct answer. All right, so do the rest of the practice, and then when you come back together, I'll show you the answer for all the practice problems. Okay, so let's take a look at all of the practice problems that you were supposed to do. Well, again, we'll start with, here's chlorine, here's sodium. Now we're going to the next 2. All right. And we're going to pause here on number 3. So for number 3, copper, which has 29 electrons, you may have written 4s2 3d9, but that's actually not true because it turns out that there's an exception to this, okay? So if you fill the copper diagram up normally, you would put 2 electrons here and 9 can fit here, and then you think you're good. But it turns out that half-filled and completely filled orbitals are stable. So if we take a look at the arrangement where it's 4s2 3d9, notice how the 4s is filled, but the 3d is almost filled. And in order for it to be full, what we can do is we can take 1 from the 4s and move it into the 3d. And by doing that, we make the 4s half filled, which is good because that's stable, and we make the 3d completely filled, and that's stable too. And again, the reason why that happens has to do with the fact that the electrons sort of act like magnets. So if you have electrons that are paired up, they have a little bit stability because they have like a north pole, south pole of the magnet. Now, the reason why electrons don't want to be in the same room is because they have both negative charges, and like charges repel. But if they are going to be in the same room, they want to have that sort of arrangement where they can get a little stability from having north and south pole. And when all the rooms in the orbitals are filled up that way, you get a little bit more stability. So they're aiming for that. So that's the reason why instead of 4s2 3d9, it's 4s1 3d10. And that happens in several parts of the periodic table. So I'll just show you. So we just did an example with copper. Silver does the same thing. It's 5s1 3d10 instead of 5s1 4d10 instead of 5s2 4d9. And molybdenum, which is under chromium, and also chromium, they do the same thing as well. In this case, for chromium, it's 4s1 3d5, and for molybdenum, it's 5s1 4d5. So note that there's exceptions there in the periodic table. All right, moving on. So we have sodium. This is sodium. Here's for number 5 and 6. All right, now let's take a look at the last example that's a little bit tricky. iron 2 plus 2. So when we looked at regular iron, we had 4s2 3d6. And you may think, oh, well, since I have 2 less electrons, it's going to be 4s2 3d4. Well, this again is not the case. And let's talk about why that's not the case. The reason why it's not the case is because when we form cations, that means positive charge, like the +2 charge, we have to remove electrons. And for the metals, which are called transition metals that are in that middle part of the periodic table, so that block in the middle part, we remove from the 4s first. So we're going to take this electron away first before we remove from the 3d. So those are the ones that you get rid of. And so for the middle block here, when you're dealing with cations, you have to remember you take from the 4s first, all right, or from the s orbitals first. All right, and finally, this is the last one. Okay, so there are some other practice problems that you are to do for this packet. Questions 9, 10, etc. So what I'm going to do is I'm going to screenshot the answers for those so you have them to check. And if you have questions, you can let me know next time I see you. So that is it for this video. We have covered all that we need to cover in terms of how electrons are arranged. In part 1, we looked at Bohr model. Now we looked at electron configuration. And I hope you found this video helpful. All right, folks, have a quality day.